All right, hello. So to get started with my project, I'm starting it up here. So we run this app setup bash script for the first time. I was having trouble getting the GUI to run on my Mac, so I needed to use Xquartz, and this was just like how I figured out how to do it. You can see here that it is now running on Docker. So we start up the program. We'll do search for term first, Shakespeare. We'll search for love, and we wait for it to process. And you can see here it gives you all the results for that search term for all the Shakespeare files. And now every time we run the script after the first time to run the program, we use this one since it skips the line for installing Xquartz. So we'll search for term again. We'll do Hugo this time. Searching for love again, and we can see here that none of the text is showing, so that's like one of the problems with my program. So a lot of times it gets stuck on the output of the last job that was run, so you have to wait for the job to finish that we just sent for the Hugo files and then run it again, and then they should show up that time. So here we're trying again, Hugo, same thing. Oh, right, and now we can see that all the text files are showing up from all the Hugo files. So next we'll do search again for the last author. You can see once again it's not going to work the first time. So we go wait for it to finish processing that job. Still waiting. We run it again. Maybe this time's the charm. Okay, there we go. And now you have all the results for those authors' files. And then we wait for that job to finish so that we can start the next one. Usually if you wait for the last one to finish, you can do it in 2 times, but sometimes if you do it too fast, it takes more. Now we'll try searching all of the files. Obviously it's not going to work again the first time, so we wait again for the job to finish. Try again. Also, the GUI looks weird on my screen recording, but it didn't look like this when or it doesn't actually look like this whenever you run it. It's kind of hard to see. Alright, so now you can see that we have all the search results for all of the files, all the authors' files. Alright, so we wait for that to finish so that we can do the next one. Oh yeah, something actually happened here with that one. I think I tried stopping and I messed it up, so I ended up having to wait a few minutes, but just cut to the next part shortly. Alright, yeah, so now we have it back again, and we'll start to show the functionality for the top N terms. So we'll do top N, Hugo, we'll do top 25. And you can see that's the top 25 words for all the Hugo text files. So we wait for the job to finish again before we start the next one. Alright, there it goes. So now we do try top N for Shakespeare. We'll do top 25 and search, and it's showing the ones from the last one, so we wait for the Shakespeare job to finish. Alright, and there it goes. So we run it again, and this time it should work. Alright, yeah, so there's the top 25 terms for the Shakespeare files. Wait for the job to finish again, very routine. Alright, so then we do the last one, and there's the terms for the last author. We just did 10 to try and keep it short. So now we'll show it for all of them. Or, oh, I guess it didn't work that time. Here, now we have now there's the files for the last author. Or, yeah, top 10. Alright, now we'll wait for that job to finish, and we'll do the top N for all authors' files. We'll do 20. It's going to show from the last job, as it does. So we wait again. Sorry if you hear my dog in the background. Alright, top N, all 20. And now it's showing us what it found for the top 20 results for all of the author files. So that's it for the demo of the actual app. So looking at the code, you can see my main just calls my app class. In there, we're just setting up all the stuff for the GUI, all the buttons on the first page. So then we come down to here we have the radio buttons for all of the authors. So it's adding onto a string that will be for the URL for the input destination for the storage bucket. So you see here, we go into storage, look at our bucket. And there you can see the data folder, and then within that folder are all of the authors. So for depending on which radio button you check, it's just adding on which folder to go into. And then we set up all this stuff. We connected to the Google Cloud platform and our cluster. We get our output file, and we merge all of the output files except for the success file to get our output.txt and return that back to the GUI. We try and delete existing output files, but as you can see, that didn't really work, so it still gets hung up on like the last job's files, but it's just how it is sometimes. So this is for the search results, and you can see, so for this iWriter, we take all of our results and we are just saying that if the line contains the term that they searched for, then we'll append that line to the output for the screen. And then the part for the top N is almost exactly the same as for the search function, except this time when we're iterating through for the results, we just output all lines that are less than whatever the user put for N, and put those out on the screen. Again, trying to delete the output files to try and get it to work better, but wasn't working too well. Oh, right, and then the processor file, which is like the jar that the jobs use to do it. So we just are, in the main function, we're just setting up the job, setting our arguments. So here I'm looking for the line. Yeah, so you can see the processor jar, then the input for that URL, which is the radio buttons we were talking about, and then the output destination, which was just the output file in the bucket, or the output path, I mean. So for the mapper, we're basically taking the text file and getting all of the words from it. We're making them all lowercase and removing any like symbols, anything that's not a letter from A to Z. And we write out the word and the file name, and then for the reducer, we're taking that, we're going through the list of all of like the file names, and we're adding a string of the word and the file name, and we're going through and adding that to the hash map. So if it already exists, we're incrementing the frequency that it's occurring. If the string, like the word, is greater than or equal to 3 in length, or we chose a few other ones for just like common words, so those are skipped. We put that all in the map, and then we have this cleanup function for the reducer that basically is taking the hash map, sorting it into reverse order so that you get the highest frequencies at the top, sorting it by the values instead of the key, since the value of the hash map is where the frequency is listed, and the key is the word and the file name. And then we just write the contents of that map, the new linked hash map that we made, of it all being sorted to print out the word, the file name, and then the number of frequencies in the document. And that's it. Thank you.